So this community meetup is actually an internal one where, I've asked Sarah to present some of the tutorials, like pretty basic tutorials that we started on introducing for Distilabel, for specifically for generating your first preference data set, and also for like cleaning and improving the quality of existing preference data sets. I'm not entirely sure if everyone knows what Distilabel is, so we'll just give a brief recap before I'll hand over to Sarah. For everyone, at least thanks for joining. And also the meeting will be recorded. So if you don't want to be recorded, feel free to turn off your camera or turn off the audio after the meetup. So I will share my screen just to give a brief overview of Distilabel. I'll kind of skim through it relatively quickly. So Distilabel is a framework for synthetic data and AI feedback, fast and reliable and scalable pipelines. So basically what we do is we take all of these LLMs on one side and the paper implementations on the other side, package that up in order to make it flexible. There's caching included, there's batching included, there's like a lot of tracing, where you don't spend all of your precious resources on potentially lost credits whenever you call the OpenAI API and there's some failure. And yeah, that's also a thing that we've gotten back from some of these user interviews that we've done, that people really appreciate that all of these latest papers are actually implemented. And also that there's a lot of security when actually scaling your synthetic data pipeline. You have this synthetic data pipeline in the form of the SDK. And then on the other side, there's like these models and prompt templates and these LLM providers and researchers. And that's actually what we try to package up within this label. So there's some key concepts. There's pipelines, steps, and tasks within those pipelines. And within the task, there's specific LLM and prompt implementations for different research papers, for some custom things that we did. And steps are like this special task, a special type of step. And then whenever you have to define your pipeline as this direct cyclic graph, you can actually run them and validate them and check if all of the input outputs are configured correctly. You eventually get a dataset as output from that. And that's like a special kind of data set that can actually be accessed after running the pipeline. So there's a lot of steps. These are used within a pipeline, don't include prompts and LLMs, and are normally used for basic data operations. And there are basically three different main types: basic generator that has input and output, a generator that just produces output, and a global step that waits for all of the input to be there and then produces the output. And that can, for example, be used for deduplication and all of these kind of things. Then there's different tasks, and these tasks inherit from steps, but then actually add some functionality on top for prompts and LLMs. And these LLM operations are like generation or scoring or many more. You can then actually use that whenever you want for scaling your synthetic data pipeline. And then for LLMs, you can use local or remote LLMs. We have all of these providers included, and actually ensure that all of the speed is aligned with the underlying providers as well. And then eventually, if you have like LLMs and tasks and steps, you can kind of make a pipeline like this. This is one that Daniel van Strien actually created. You might load your data set, do some filtering, then ask multiple models simultaneously, asynchronously, to actually summarize some of your data. Then you combine columns within your data set, and eventually use something like ultra feedback for rating your models. And then you can actually push that data set to Argilla within like this pre-formatted functionality that we configured for specific dataset settings, or you can export it to the hub and kind of go from there and maybe use some other library. Yeah, there's some cool features for steps, tasks, and pipelines. They're fully customizable. There's the resource allocation. So for example, you can say, okay, I want this number of CPUs assigned to these steps, and all of these things also apply to tasks. And then for the tasks, these are normally based on verified research papers, and there are different scopes, as mentioned, for maybe instruction or response generation or tuning or rewriting. You can also do predictive task generation, preference and scoring and judging, and also things for critique and reasoning. So like all of the bells and whistles are basically included. Then for LLMs, you can do model pooling to create more diverse generations with different models. You can also do structured generations based on outlines of instructors. You can actually do that because we implemented that within this label as well. And then when you wrap all of these things within a pipeline, you can actually verify the pipeline. There's caching of intermediary results. So if your pipeline fails, you can actually continue where you left off. Everything is serializable, shareable. You can push the pipeline to the hub along with your data set. So if you find a cool data set and with a Distilabel pipeline on the hub, you can actually load that data set, maybe change it a little bit, and then create your own version of that. So that's also pretty cool. And as of recently, we actually have this Gray integration to actually be able to scale to like millions and millions of rows. And these are some examples of instruction tuning generation where you have maybe an input, an AI app description, and then a generator task can be any generator task that you link up with an LLM. And then you just generate like multiple instructions from that. And as you can imagine, that's also how you would go about creating your initial preference data set. And the next step would be scoring, where you label or score with an LLM. And then based on this score, to create your initial preference data set or clean your preference data set as well. And now I'll give it over to Sarah.
I think it should be working.
Yeah, maybe you can zoom in a little bit.
Okay. Mhm.
Yeah, for me, it's fine.
Okay, great. So let's start with the notebook about generative synthetic preference dataset. Normally, we use preference dataset for DPO or ORPO, but there are also other alignment algorithms. In this case, we'll use Argilla because we want to gather human feedback and curate our data. And we also use the Hugging Face inference endpoints because they are free and although they are limited, for our case are perfect. And we'll see in detail the components later. So we'll need to install Distilabel, of course, with, in this case, the extra for the Hugging Face inference API. Then we can make the required imports and to use the Hugging Face inference endpoints. And also, maybe later, if we want to push the dataset generated to the hub, we need a Hugging Face token, and we can log in and use it within this node with NMBAR, or also using, for instance, the collab secrets and enable it, or you can manually write it. And as mentioned, we will use Argilla, but to load the data to Argilla, we need an Argilla instance running in the background. So if you follow this guide with just a few clicks, you will be able to set up a complete Hugging Face space where you can load the data. And we will, of course, need to install the Argilla extra. So as mentioned, Distilabel works with pipelines, and these pipelines need different steps. But the steps need inputs, make some kind of process, and then generate the outputs. And we will go over each step in detail to better understand this process and how they are connected in our pipeline. So we'll start by loading a dataset from the hub. That's why we will use this component. And we'll use this dataset that is just an example with a few rows. In this case, we can use the hub embedded viewer. And we can see that it just have this instruction column and the topic column. So quite basic, but it serves for our use case. And the next step is to generate the responses for those instructions. In this case, we want two responses, and we will use the Llama 3 and Mixgraph. But you can also use any other model available in the hub. Normally, worms are those that better work, but sometimes maybe that they are overloaded. But for those cases, you can use another LLM. In this case, we'll use the text generation task. It's very basic because it will only answer our instructions and create generations. Here we have an example, which are the top cities in Spain, and we got a generation for the Llama 3 and a generation for Mixgraph. Now that we have two responses, we can continue with the evaluation. To evaluate and use the ultra feedback task to judge these responses needs generations. That is a list of both generations together. And that's the reason why we use this intermediate step, the responses step to, for instance, here, we will get the list. And now that we have all the correct inputs for evaluating the responses, we can use the graphical task that evaluates fullness, honesty, instruction following, or truthfulness to evaluate with the artificial intelligence feedback how well, how good they are. Finally, as we want a preference dataset, we have two different options. On the one side, we have the option of manually create this format of prompt chosen and rejected with the formatted generation DPO that will just go over the artificial intelligence feedback that we got and generate the different columns, chosen rating with the chosen model 2, and the normal format that is used. Or we can use Argilla to further curate the data and label or give feedback and check that both the generations and also the feedback is good enough for our data. So we can improve the data quality and ensure that it will work better with our model. So now that we have all the steps, we need to join them in the pipeline. We need to give a name to the pipeline, in this case, just the generate dataset name, and gather all the steps. For instance, here, as we've seen, the dataset, latent responses, etc. And in this case, for Argilla, make sure to write the correct AP URL that you can find in your space, or if you're using another way, for instance, Docker, it will be the Docker URL. If we have our Argilla instance and we log in, we can go to my settings and from here just copy the key and add it. And the way in which the steps will be run is how they are connected. So doesn't matter how we write them here, but how we indicate here that they are connected. And for that, we have two different options. The first is use the connect method, and the second, this operator. But you have to make sure and take into account that, for instance, the connect method doesn't allow lists. So, for instance, to connect them, we need to loop over the tasks, while using this operator, you can just write, for instance, the generated responses, that is the list, and continue connecting the steps. And also, we can connect a single step to different steps. So in the docs, if you check or you want more information about this, is further explained. And also maybe if you need to connect a batch to a downstream step, is also possible. So there you can find more information. Then now we have our pipeline setup and we want to run it. Now we make sure that this will work, but when you are experimenting with different steps or even your own steps, you don't want to run all the pipeline. So this dry run method is quite useful for experimentation. By default, we run with just a batch size of one, but you can set the one that better suits your needs. And finally, we run the pipeline. Why they use cache? Because common question is what happens if, for instance, you are running a pipeline to generate thousands of columns and data. The pipeline fail. Maybe it's not your fault. Maybe it's a connection error or a model error. And here the worry is if you lose the data. And the answer is that no, because all the data will be saved in our cache, and the pipeline, once you run it again, will start from when it stops. So there is no problem for that. And now that, so we can run this pipeline and see if we push to the hub the dataset, the generated data. In this case, is if automatically was generated. We can see here the instructions, generations. This is the Distilabel metadata, but you can choose if showing it or not. But I think that in this case can be useful because it shows the raw answers, the model name, etc. And here we have the preference dataset. You can see that we have the instruction and the generation for the first model and for the second model. We also are improving in Argilla the view, so probably then we can also use the chat field that will show us this also in a different way. It can be easier to read, but I think this is quite nice. And here, why there are here marked things in the questions. And the reason is that those evaluations and responses we got when we evaluated with ultra feedback were now added as suggestions. So this is supposedly the A4 for this first generation, a 2 for the second one, with ultra feedback. We can here edit these answers and then submit or save or whatever. And here we will see the progress on the guidelines if they are added. So that would be for the preference dataset. If you have any question, maybe I can answer now or I can continue later and see all of them.
I have one question that is probably out of scope a little bit, but if I wanted to create a dialogue and I don't know how many turns this dialogue is going to be, is it possible using platform?
You mean for Argilla?
Yes.
I think we are working for that, but we can, at the moment, we can directly log, for instance, from a dialogue, the chat in Argilla, but we are working for that.
Thank you.
Yeah. So I guess you're talking about the generation specifically, right?
Yes.
So there's this task that research paper recently launched or introduced, and that task is called Magpie. And along with that task definition that we've actually created, we actually allow for passing the terms. So whenever you run your Distilabel pipeline, you can actually define specific runtime parameters, both for your LLMs and for your tasks. That kind of fine tune how you would like to use them. And for Magpie specifically, you can pass the number of turns. So based on that, you can actually create longer, or shorter conversations. And yeah, also, for example, for certain tasks, you would be able to slightly adjust the prompt as well to steer it specifically to your direction. There's one example of a task that is also for predictive models, like for RAG-like scenarios for re-ranking and retrieval. And there you can, for example, define whether you want to generate data for re-ranking or for retrieval, or if the set this should be very similar to your domain or less similar. And then we provide some customization options there.
Thank you.
Okay, cool.
Okay, so we'll continue with the second part that will be how to clean an existing preference dataset. And this is quite useful, for instance, if you already have a preference dataset and you need further curate the data to improve the quality. So as in the previous notebook, we will use the same libraries, but different components. And then we need to make the required installations, imports, and we'll also set up here the having face token and deploy Argilla. Here we can see that it's already in the from chosen and rejected format with the system column 2, but in this case, it will be not relevant. And then we will load it. with just a few samples for this case, and we'll shuffle the chosen and rejected columns to ensure that when we evaluate these responses, we can avoid any bias in the dataset. But this is quite raw. We didn't mention this, and we won't run this directly because it needs to be done and added to a separate module from where we import it and then add it to our pipeline. But just for as example, this will be how a shuffle step, for instance, that we name it like that, is written. You can add here any requirement. For instance, imagine you want to add as a pre-processing step an NLTK step to lowercase the sentences. Here we written, for instance, those that will be input to the shuffle step and the outputs and how it will works. Here we will give, for instance, the instruction we've seen, the same as here, but as a step. And we will need to import. So we can continue now by defining the pipeline. As previously, we will go in detail into each step to better understand this. So we will load the data set that we already pre-processed with the load data from this, because in this case, we are not using the hub. And it will load all the columns. But until this moment, we've seen that the input and the output columns have matched. But in this case, for evaluating responses, we need that the question will be named to instructions. And that's the reason why we use the output mappings. This means here that the input column will be renamed to instruction. And this will be renamed also for the subsequent steps. If you don't want to keep, for instance, the rename of instruction, you need to use the input mappings, but for instance, input mappings also question instruction. So as before, we use also ultra feedback because it's quite good, but an improved model because it's Llama 3.1 with 70B. If, for instance, you have an SFT dataset, the workflow is quite similar. And we also have this Prometheus eval task that can also evaluate just the given instruction and response. And always in the LLM or task gallery, you can check these things in our documentation. So you can have all the information there. And we continue. We have the same issue as before in the input columns that are instruction generations, but in this case, we already pre-processed the data and we have generations, so we don't need to combine any columns. And we see also ratings and rationals. As we have seen, there are many columns, and maybe for our use case, this can be confusing. So you can use intermediate steps to select the columns that we need. In this case, we want to clean it with a manual clean of the data with Argilla. So now we'll gather all these steps and we'll in this pipeline with the name clean dataset. But now we have added also two different arguments. One, because as we mentioned, we can save the pipeline run in the cache, and so we can select here where to save this cache. And also, if you require, you can add the requirements here. In this case, that we need Distilabel. But for more complex pipelines, they can be really useful. So we added here the steps as previously we connected them. However, if you take a look at the LLM, before we were adding here the arguments, the runtime arguments, that's okay. But you can also add in here as parameters when running our pipeline. So there is no problem for that. We run our pipeline, as we say, and we get in Argilla our dataset we mentioned. We have it here with the instructions generations. In this case, when I ran it, the model was a bit overloaded. The next ones, they have it. So it shouldn't be a problem. And in any case, you can always use the inference points or other LLMs as you prefer, or even models, because as we've seen, you can select in the hub those. When pushing the dataset, we have here the dataset that we got. In this case, there are no sets because we finished with the to Argilla step. There are no steps. There are no two steps. We can see here the instructions, generations, all the data we need. And with that, we will get our dataset, our preference dataset, or even, as I mentioned, the safety dataset clean.
Cool. Thanks, Sarah, for the presentations. There were already some questions within the chat, but does anyone have other questions, maybe about Distilabel specifically, about the tutorials, or maybe about Argilla even, or Hugging Face? Feel free to ask. I have a question. Sarah, you've been working on this task for predictive data generation. Where do you think you see these kind of things going from using Distilabels for generative tasks and labeling?
Do you mean how it works or how it's useful?
Yeah, just how it works and maybe how you see that playing together with Argilla and model training.
Yeah, I've been working on that. I think it's quite useful because the idea is be able with this level generate this type of data with text classification or even token classification. I think that now there are many data sets, but not all of them, for instance, are usable or have the specific data that we require for our use case. And that's the reason why I think can be quite important to then be used in our models. For instance, we want to create a tutorial to fine-tune a set fit model, but it can be used with any other cases. I think that can be quite useful for the community in this case.
Yeah, then would be cool to kind of infer some knowledge from an LLM and then directly create a smaller, way more efficient model. I think set fits, you don't need that much data and really is really quick. So that's pretty cool. And on top of that, what we're also exploring, for example, is actually using this label in such a way that you can kind of use it directly within the Argilla UI. So there's a lot of integration possible for this label in Argilla as well that we're exploring. There was one question about Argilla having a central compute location. Both Argilla and this label are fully open source. We have this docs.argilla.io that actually has tutorials. We try to keep it bare bones for now. There's tutorials to come. Some of them that will be added during the next release. We have some image preference generation datasets and some chat preference generation datasets, and we actually explain how to configure Argilla for these kind of scenarios, but there's way more scenarios due to the fact that Argilla is fully configurable. So you can actually choose kind of questions you want as input, like text, image, chat, or these kind of things, and what you expect your annotators or your curators to review and evaluate. And those are maybe label questions, multi-label questions, markdown text, and these kind of things. And on top of that, what you can do is actually configure like metadata, vectors, a lot of these things to filter through your data way more efficiently. So as a scientist, you normally kind of think about feature engineering in a way that you would normally do, but then specifically these features you can actually add to Argilla, and that's kind of allows for way more efficient data curation. And normally, for example, for something as assigned labels, you can just look at the log props and then filter to very certain or very uncertain labels, and then you end up like finding these edge cases that you don't want within your data. And the same holds for this label. So I think within the dev branch, there's slightly more tutorials currently, but we will release a new release soon. And along with the tutorials, we actually have these overviews of paper implementations as well. So for example, the filter feedback paper is a way more extensive pipeline than the one component for scoring that we used. And we found it interesting to use this label for reproducing pipelines paper, so to say, as a exercise to see how it might work and what are the limitations whenever you actually work with synthetic data generation. Are there more questions? Otherwise, then we'll say goodbye. The video will be uploaded in a couple of days and will actually be shared as well via the Luma platform where you sign up. And if you are interested in providing feedback for this label, you can join the Discord. If you are in joining or presenting something during one of our meetups, feel free to reach out or send an email. See you in a couple of weeks. Bye-bye.
Thank you.
Bye. Thank you.